All right, guys, welcome to this page of the notes, and what we're going to do is another example problem dealing with logarithmic functions and word problems, sort of a real-life situation. In the previous problem, we saw how pH is actually a logarithmic scale. You're taking the concentration of a hydrogen ion or the the hydroxide ion and converting it to a logarithmic scale so that you take these kind of ugly scientific notation numbers and convert them into something nice. pH is not the only thing that has a logarithmic scale. When measuring the intensity of an earthquake on the Richter scale, that is a logarithmic scale. You take the intensity of an earthquake, which is measured by measuring the shock waves moving through the ground, which are going to be these enormous numbers in scientific notation. We convert it to a logarithmic scale and you get out the number read off the Richter scale. Another example would be the intensity of sound, right? So when you're listening to someone speaking to you, or you hear a car drive by, or a plane fly overhead, right? The intensity of the sound that you hear is converted to decibels. But the decibel scale is a logarithmic scale. So you know that when you hear somebody, say right now you're listening to me talk to you, I'm producing sound waves, and those sound waves are measured in hertz, a frequency. We convert that frequency, which is almost always going to be a number in scientific notation, kind of an ugly number, we convert it to a logarithmic scale using this equation, this formula, which has a log in it, convert it to a logarithmic scale to get out a decibel reading, which is going to be a much nicer, neater, easier number to work with, right? So, for example, instead of saying that an airplane has an intensity of sound that's 6.02 times 10 to the 15th hertz, I can be like, the intensity of sound of a jet engine on an airplane is 120 decibels or whatever it is, right? It's just a much nicer, neater number. So here we go. Let's talk about the decibel level of just a normal conversation, right? If we're having a conversation together about what is the intensity of sound in decibels for a normal conversation. All right, here's the formula for converting to decibels. Obviously, D stands for decibels, and I is going to be the intensity of the sound that you hear, right? So there's an intensity of sound for a whisper, intensity of sound for a normal conversation, the intensity of sound of a car driving by, a plane flying by overhead, right? What is the intensity of the sound? The frequency of the wavelength for that sound will always be given in hertz. We'll go convert that to a logarithmic scale and get decibels. All right, so here we go. Let's start off with the formula that we've been given. D is equal to 10 times the log. It's a log base 10. I'm not going to write the 10. You just know you can use the button on your calculator. I, the intensity of sound, over 1.0 times 10 to the minus 12th. The reason that this 1.0 times 10 to the minus 12th is in there is because for the average human being, this is the lowest intensity sound that our ears are capable of detecting. And again, that's for the average human being. And obviously, the older you get, the more difficult it becomes to hear sounds this low of a frequency. But again, it's for the average human being, this is the lowest intensity sound that they can hear. Now, what I've told you is I want you to find out the intensity of a sound produced by a normal conversation. So we're going to be solving for the intensity of the sound of a normal conversation if, when you're just having a normal conversation with someone, the decibel level is 60 decibels. So that's going to go in for our decibel level. D is going to be 60. It's equal to 10 log I over 1.0 times 10 to the negative 12th. All right, so we're going to find what is the frequency, about the frequency of the sound waves that you are producing when you're just having a normal conversation. Again, on the decibel scale, it's a 60, which is a nice neat number. Oh, a normal conversation is about 60 decimals. That's so easy to describe. What we're going to find is a number that's in scientific notation, which generally freaks kids out, and that's why we convert it to a logarithmic scale, so that you get these nice neat numbers. But just like with the pH, we're going to go the opposite direction. What is the intensity of the sound? Well, the first thing I got to do to get that I by itself is move the 10 out. So I'll divide both sides by 10, and I wind up with 6 is equal to log I over 1.0 times 10 to the negative 12th. Again, I should hopefully right away kind of recognize this is the good old trusty snail method. So I start with my base, which is 10, and I work my way around the equal sign. That 10 is going to be raised to the 6th power. Just keep going. Equal to I over 1.0 times 10 to the negative 12th. All right, if you got yourself a calculator there, you probably don't need a calculator to do this for you, but to get that I by itself, I'll multiply the 1.0 times 10 to the negative 12 to the other side, and so I, the intensity of the sound of a normal conversation, is going to be 10 to the 6th multiplied by 1.0 times 10 to the negative 12th. And if you do that, certainly feel free to use your calculator to help you out. You should get 1.0 times 10 to the negative 6, and that's going to be in hertz for frequency. Again, I just want to drive home this idea of why we use logarithmic scales. Instead of saying, oh yeah, the intensity of a normal conversation is about 1.0 times 10 to the negative 6 hertz. Or we can convert that number in scientific notation using a logarithmic scale to the decibel scale. And I can say instead, oh, the intensity of sound of a normal conversation is about 60 decibels, right? 60 is a much nicer number than having to use this number in scientific notation. Right? We're just converting to a logarithmic scale to help keep our numbers nice and neat. All right, guys, that's the way these problems are going to work. I expect, if you're taking this class with me, there to be quite a few word problems on quizzes and tests coming up, so that you can both show me what you've learned about logarithms and see how it applies to describing all sorts of natural phenomena that occur around us. Guys, I really enjoyed doing properties of logarithms with you. Thanks so much for joining me. I'll see you next time.